The idea of key-value pairs comes up over and over again in data science. For example, it's central to the way that Hadoop is implemented, and also central in NoSQL databases or NoSQL databases. In this video, I'm going to talk about how Python implements this idea of key-value pairs, which is in Python called a dictionary. Now, as usual, what you're looking at is the Spyder IDE that is running on a Windows instance running at Amazon Web Services. There are a number of ways to construct dictionaries in Python, but one of the most straightforward ways is just to use the dictionary name, which I've called SKUdict in this particular example, and then an equal sign, and then between the curly brackets, place your key and value pairs separated by a colon to distinguish the key from the value, and with the entire list separated by commas. Now I'm building on our example of products in a grocery store. So in this particular dictionary, the keys, which are here on the left-hand side of these pairs that are separated by the colons, are representing product SKUs. And that's why I've named the dictionary here SKU Dictionary. So down the left-hand side of the pairs, we have the SKUs, which we're specifying as strings. And on the right-hand side of the pairs, we have a description of the product, which is also a string. So in this particular case, the product that corresponds to the SKU Milk 23 is called VG Skim Milk. Now, as we get into this example, I want to make sure that you understand a couple of things. In the example, both the keys here and the values happen to both be strings, but that does not necessarily need to be the case, either for the keys or for the values. Both the keys and the values can be pretty much any kind of object that you find in Python. The other thing that I wanted to emphasize is that the keys have to be unique. The values certainly do not have to be unique. They can be repeated for different keys. But the keys are unique. And if you make a typo in the definition of your dictionary and duplicate a key, what's going to happen is you're going to end up with only one key-value pair for that key, and one of them is going to have overwritten the other one. So this is an area where it's easy to make a typo, which will introduce a bug into your program. So the keys have to be unique. So I'm going to go ahead and create this dictionary by running this Python code that I have here in the editor window. And I'm going to go ahead and use the idea of cells that I introduced in a previous video. You'll notice that I have this string here, pound %%. Pound is the comment character, and %% turns this into a cell boundary. And you'll notice I have another pound %% starting this next piece of code here that we're not going to talk about yet. But once I've defined cells in this way, I can execute all of the code in a cell by doing Control-Enter. So when I press Control, hold it down, and then Enter, this block of code will be executed in the interpreter window over here on the right. So to make this a little bit easier to see, I've gone ahead and made the console window here on the right as big as I can, keeping it in the right-hand part of the screen. Now, if in the console over here I just type out the name of the dictionary, SKUdict, and hit Enter, it will print out the dictionary, and you'll notice that it uses more or less exactly the same format that I used to define the dictionary. The most basic things that we're going to want to do with the dictionary are to reference particular items and then also to assign particular items. So to reference an item, I just type the dictionary name, SKUdict. I use square brackets to access items in the dictionary, and then into those square brackets I put the key. So for example, if I wanted to access the description of cereal 12, I'm going to type quotes and then cereal 12 and then quote in the square bracket. And then if I execute this line of code, which I can do by pressing F9, you'll see that SKUDict of Sir12 was executed, and it did in fact return the value of this key value pair, which was very good cornflakes. Now, in addition to referencing values in the dictionary, you also may want to assign them, and you do this in an obvious way, which is use the name of the dictionary and then the key whose value you want to change. So let's go ahead and change Sir12, and then you close the square bracket, use an equal sign, and in this case I'll reassign the value for Sir12 to very good corn flakes, and then I'll put in the parentheses here test to indicate that we are testing the assignment. So now if I execute this line of code by hitting F9, you'll see that it executes over here in the console window on the right. And now if I print out the dictionary, you'll see that for Cereal 12, the value is now VG Cornflakes test instead of what it was originally, which was VG Cornflakes. So what I just did was change the value associated with a key, which was Sir12, that was already in the dictionary. What happens if I assign to a key that's not already in the dictionary? Well, let's give that a try. So if I go SKUDict and then some kind of new key, so we've used up to Cereal 14, so let's use Cereal 15, CER15, and then assign it a new product description. So this might be VG Rice Flakes. Now if I go ahead and execute this line of code, again by hitting F9, you'll see it executes over here in the console. If I now print out the dictionary, you'll see that it has an additional entry for Cereal 15, CR15 over here, that says VG Rice Flakes. So when I assign to a key that's not already in the dictionary, the key is just inserted into the dictionary. Now I want you to notice that when this dictionary printed out over here, the ordering of the key value pairs was different than the ordering that we used in specifying the dictionary. And in fact, in Python, dictionaries have no order. So you cannot be certain about the order of any of the items in the dictionary, only that the keys are associated with the values. So for example, if I try to access a particular dictionary item the way I would if it were a list, for example by saying SKUDict1, which would return the second element if this were a list, what I'm going to get is an error. So there is no ordering to a dictionary. The only way this SKUDict of 1 would work is if 1 happened to be a key somewhere in that dictionary. Then it would return to me the corresponding value. The fact that dictionaries have no order also means that they can't be sorted, either by their keys or their values. In order to think about sorting a dictionary, you have to first change it into a data type that has ordering. That is, you have to change it into something other than a dictionary, and then think about sorting it based on either its keys or its values. But at that point, it's really no longer a dictionary because, once again, dictionaries do not have an order in Python. Now, I mentioned earlier in this video that there are other ways to create a dictionary and load data into it. And in fact, another one is suggested by this property that we observed, that if you assign a value to a key that does not exist in the dictionary, then a new entry for that key value pair is created. And the second way to create dictionaries is to begin by creating an empty dictionary and then loading the key value pairs into the dictionary using the method that we used before. So to create an empty dictionary, you can use the name of the dictionary, which in this case is SKUDict, and then an equal sign, and then just a pair of curly brackets with nothing in between. You can then go ahead and load in the key value pairs by using the dictionary name SKUDict, the open square bracket, the key that you want to create, and then close the square bracket, and then just equal the value that you want to load into the dictionary. So this, as I said before, is identical to what we did in the last example, and you can just go through and then load in all the key value pairs that you want. Once again, it's very important that these keys are unique. If they aren't unique, you will just end up overriding the value from an earlier key. Now, if you have just watched my videos on objects, it may have occurred to you that virtually everything in Python is in fact an object. And that turns out to be correct. Dictionaries are objects, as are lists and strings and virtually everything else that we've talked about in this series of videos so far. The class constructor for a dictionary is the word dict. So, for example, a second way to create an empty dictionary would be to use SKUdict and then equal sign and then the class constructor dict, and I do open parentheses and close parentheses. And this will also create an empty dictionary. Now, since dictionaries are objects, there's a variety of methods associated with them, and I wanted to just show you a few of them and then talk about how you can find out more information about the other methods. Two of the most important methods for dictionaries are the methods keys and values, which retrieve, respectively, the keys from the dictionary and the values from the dictionary, and they will retrieve them in the same order. So, for example, I can get a list of the keys of my dictionary, SKUdict, by going dot and then keys, and then open paren and close paren. This will execute the method keys on the dictionary. So let me go ahead and execute this by typing F9. And you can see that it gives me a list of the keys from that dictionary. And in fact, the type returned by the keys method of the dictionary does in fact return a list. Similarly, I can get the values. So if I go SKUdict values, open paren and close paren, and then run this line of code with F9, you'll see that I also get a list, but this time it contains the values from that dictionary. The method keys and the method values will return the keys and the values in the same order, but there's no guarantee that if you run this program at different times or on different computers or change in anything in any way that you're going to get the list of keys in the same order that you did when you ran it this time. Dictionaries have no order, but when you run the keys and the values methods within one program, you're going to get the keys and the values out in the same order. By the same order, I mean that a key and the value in the same position in the two lists will in fact be the key value pair that belongs together. Next, I want to show you the methods pop and pop item. The method pop removes a specified key value pair from the dictionary and returns the corresponding value. So let's take a look at that. So if I go SKUdict and then pop and then specify a key, so I'm going to go ahead and pop milk25. What should happen is that the key value pair for milk25 will be removed from the dictionary and the value for milk25 will be returned. So let me go ahead and run this with F9. And you'll see that VG 2% milk is returned, which is the value for milk25. And now if I print out the dictionary, SKUdict, I should see that milk25 is no longer in there. So you can see there's milk 23, 24, and 26, but the key value pair for milk25 has been removed. The dictionary method pop item is very similar to pop, except that you don't specify which item should be removed from the dictionary. So pop item just returns an item from the dictionary and removes it, and when it returns it, it returns both the key and the value pair. So let's go ahead and see how this works. So SKU dict and then pop item. And now if I execute this line with F9, what you'll notice is that what was returned had the key of SER14 or serial 14 and the value of very good toasted rice. And now if I print out the dictionary, SKU dict, you're going to see that serial 14 is no longer in the dictionary. Now pop item just removes an item from the dictionary. You don't know which one it's going to be, so the logic of any program that you write cannot depend in any way on the order of the items in the dictionary. And of course it shouldn't, because dictionaries once again do not have any order. But pop item can be used in a loop just to pop off all of the items one at a time from the dictionary. Now I wanted to say one other thing here. The type of the returned key value pair is something called a tuple. You can think of it as being like a list. It's actually almost identical to a list, except that the elements in the tuple cannot be changed. I'm going to talk about tuples in more detail in a later video. So I have one more method that I'd like to show you, and that is a method for testing whether or not a dictionary has a particular key. I have cleared the console window here on the right with Control L, and I'm going to print out the current state of the dictionary. So our dictionary is SKU dict. So these are the key value pairs which are currently in the dictionary. Now if I want to test whether or not a particular key is in the dictionary, I can type the key. So I'll go ahead and do this over in the editor. So I'm going to type the name of the key. So let's just pick one, say Milk23. And then I can test if Milk23 is in the list of keys by using the keyword in and then just the dictionary name. So now if I run this line of code in the console by typing F9, what you'll see is that since Milk23 really is in the dictionary, this returns the value of true. So let's just test what happens if we test for a key that's not in the dictionary. We should get obviously a value of false. But let's suppose we type milk and 2, maybe it's a typo, in SKU dict, and now run this code in the console. And milk2 is not one of the keys in the dictionary, so you can see that milk2 in SKU dict returns false. So these are all of the methods for dictionaries that I want to talk specifically about at this time. Since dictionaries are objects, I can use the dir command to get a list of all attributes and methods of a dictionary. So if I go dir of SKU dict, I will get a list of all of the attributes and methods for this dictionary object. Now recall that anything that begins with a double underscore is intended to be private, so the only things I should really be looking at are the things at the end of this list that are intended, so to speak, for public consumption. So for example, you can see here is the method keys that we used, and pop item, and then values. The dictionary class has obviously a variety of other methods that you can learn about, and I did want to just very quickly make sure that you knew how to get additional information about these things. By far the best way is to do a search. So I've fired up my browser, and now I'm going to search for Python, and then dict, and then methods. And the first two links that I get are to python.org's, which is the official website of Python, documents. So here's one for Python 2.7. So I'm going to go ahead and open that one, and you'll see that if I look down the table of contents here, I'm going to find documentation about dictionary. So mapping types here is the dictionary, and if I click on that documentation, you will see a discussion of all of the methods that this data type has. So for example, here is the keys method that I showed you. Returning to Spyder and our Python dictionary SKUdict, I want to make sure that you understand that you cannot create copies of dictionaries just by assigning their names. So for example, if I take a variable named testdict and assign it SKUdict, that assignment will work just fine, but I have not created a new copy of the dictionary. All I've done is create a new name that points to the old copy of the dictionary. If I print out test dictionary and then print out SKU dictionary, I'll see that the data shown is exactly the same. But now if I take SKUdict and I change one of the items, like for example SIR 15, so let's say I change SIR 15 to hello, then what I'll see is that test dictionary, testdict, also has serial 15 changed to hello. So the name testdict and the name SKUdict are pointing to exactly the same data. If I actually want to create a copy, then I have to do something like testdict is equal to dict, the dictionary constructor of SKUdict. And in this case, what will happen is that a copy of the dictionary down through the level of the data will have been made by the dictionary class constructor. So let's take a look at this. Testdict now looks exactly the same as SKUdict. Okay, you'll see that they both have the change that I made just a moment ago, but otherwise they are identical. But if I take, for example, milk23 and change it to hello as well, so SKUdict of milk23 is now going to be equal to hello as well, then I'll see that change when I print out SKUdict. There it is, there's the second hello. But when I print out testdict, you'll see that milk23 has not been changed. So be careful about assignment. Any assignment like testdict equal SKUdict is not creating a copy of the dictionary. All it's doing is creating a new name that points to the same data. In order to actually create a copy, I have to do something more, such as, for example, use a dictionary constructor. So this is an important idea to understand, because if you don't understand it, you're likely to introduce bugs into your code because you have not created copies when you think perhaps that you have. Now, the very last thing I want to do in this introductory video about dictionaries in Python is make sure that you understand that dictionaries can be used in a more complicated way than we've used them so far. So far, both the keys for our dictionary and the data in our dictionary have both been strings. But that, of course, doesn't need to be the case. Both the keys and the data can be virtually any kind of Python object. The keys, of course, have to be unique. So in this more complicated example, I'm going to build on what we did in our videos about objects in Python, in particular what we did in the last video, Python with Spyder 11, which was about inheritance. And let me just remind you of what that was. I also have open here in the editor the code file for Python with Spyder 11. And what we had done in that video was first to define an object class for product, and then inheriting from product, we defined two additional classes, a milk product class that inherited from product but also had data that was specific to milk, and a laundry detergent product class, again inheriting from the class product, but this class having data that's specific to laundry detergent. Now what I'm going to do first is execute in this Python session the definitions of those objects. So I'm going to go ahead up to this very first class definition for product, and I'm just going to execute all of the code in that cell by doing Control Enter. So I've now defined the class product. And now I'm going to go down to the definition of the two product classes for milk product and for laundry detergent product, and I'm going to execute the class definitions for these as well by putting the cursor in the cell and doing Control Enter. So I've now defined the milk product, and then finally I need to do the same thing for the cell defining the laundry detergent product. Okay, so as of now in this Python console session, I have object classes defined for product, for milk product, and for laundry detergent product. So now I'm going to go ahead and go back to my code from my current video, and I'm going to slide on down to the very last code cell in the file, which defines a dictionary where the keys are still strings, but the data are objects that are created with the milk product and the laundry detergent product classes. So for example, in this particular dictionary, I've defined 4 milk products, and I've done so by first creating an empty dictionary and then adding each new milk product by specifying a new key. So for example, milk 23 is very good skim milk. Milk 24, the milk 24 is intended to be the SKU, is going to be 1% milk. Milk 25 is 2% milk, and I see I've specified the milk fat level correctly here, but I have an error in the name, so let's change that to 2%. And then finally, milk 26 is going to be whole milk. And then I start defining laundry detergent products, and I've defined 3 of those. Detergent 16 is going to be a liquid HE detergent. Detergent 17 is a liquid detergent that's not HE. You may recall that HE stood for high efficiency. And then detergent 18 is going to be a powdered detergent that's also not HE. So I'm going to go ahead and execute the definition of this dictionary here in this cell. So I'll do Control Enter to execute that cell. And now I should have a dictionary called SKUDict that instead of having strings as data is going to have objects as data. So now when I print out SKUDict, you'll see that each item is listed, det 16, 17, 18, as well as the milk products, milk 23, 24, 25, and 26. And I now can access data within those objects in the same way that I would access that data had I defined separate objects that were not part of a dictionary. So for example, for milk 25, which I would reference by SKUDict and then milk 25, now milk has an attribute of fat calories. So if I do .fat calories, I will see that for milk 25, now milk 25 was 2% milk, the fat calories in a serving is going to be 43. Now fat calories doesn't exist for the laundry detergent products. So for example, if I did SKUDict of detergent 16 and then tried to access fat calories, I'm going to get an error. And sure enough, I get an attribute error because laundry detergent doesn't have an attribute called fat calories. However, laundry detergents do have an attribute called sudsing level. So if I go SKUDict and then pick one of the detergents, so let's do detergent 16, and then reference its sudsing level, what I'll see is that detergent 16 is in fact a high efficiency detergent, and so it would have a very low sudsing level. And finally, if I had tried to reference the sudsing level for one of the milk products, of course I would get an error. So in this example, I've built a dictionary where the keys are strings as before, but the data happens to be objects. And I can see that when I print out the dictionary, because what happens is I see the keys and then the colon, and then the data that's shown is shown in this syntax, which is quite obtuse: main.laundry detergent product instance at a particular address. But that's indicating that the value part of the key value pairs in this particular dictionary are objects. So this concludes my discussion of dictionaries in Python. Dictionaries again implement the idea of key value pairs, and the concept of key value pairs is very important in many programming contexts, including many contexts in data science.